Hello students, I, Mrs. Madhavi Mhatre, welcome you all in the next lecture of Mathematics 1. I hope all of you are doing well at home. We are studying chapter number 2, Real Numbers. In that we have completed properties of rational numbers, properties of irrational numbers, and then we have learned that rational numbers and irrational numbers together they are called as real numbers. Now we are studying about surds. Surds is nothing but the irrational root. Surd is also called as an irrational root of a number. Then we have studied about comparison of quadratic surds and operations on quadratic surds. Now we have come to an end of this chapter and we are studying the topic rationalization of quadratic surds. We have studied that when the product of two irrational numbers is a rational number, then they are called as rationalizing factors of each other. For example, root 3 into root 3, root 9 which is equal to 3. So we can say that root 3 is an irrational is a rationalizing factor of root 3. Similarly, for 4 root 3 also, root 3 is going to be the rationalizing factor. So root 3 is rationalizing factor of 4 root 3. Similarly, 4 root 3 is rationalizing factor of root 3. But when we are rationalizing the surds, that time we are going to think of a simplest surd. We have studied that for a surd, there can be innumerable rationalizing factors. But we are always going to think of a simplest form. Like for root 8, we can think that for root 8 also is a rationalizing factor because root 8 into root 8 is root 64 which is equal to 8, a rational number. But for root 8, the simplest factor or the simplest rationalizing factor is root 2 because root 8 into root 2 we are going to get root 16, that is 4. Okay, so for root 8 we can have root 8 as a factor, we can have root 2 as a factor. Root 8 we can express as 2 root 2. So 2 root 2 also can be the rationalizing factor for root 8. So it is not like that every irrational number has a unique rationalizing factor. Okay. So this we have seen under this point that rationalizing factor of a given surd is not unique. Okay. So there can be many rationalizing factors. Then if a surd is a rationalizing factor of given surd, then the surd obtained by multiplying it with any non-zero rational number also can be a rationalizing factor. Like for root 2, we can have root 2, we can have 2 root 2, we can have 3 root 2. Okay, that means root 2 we are multiplying by non-zero rational number and all those are rationalizing factors for the given surd. Okay. So here in this way we can have innumerable rationalizing factor for the given surd. It's not like that every surd is having only one rationalizing factor. But while solving the problems, always we are going to take the simplest surd or the simplest rationalizing factor. Okay. Now let's go further. Now let us see the solved examples. Here find the rationalizing factor of root 27. Whatever I spoke now you will understand it better. Okay. So root 27 is an irrational number or it is a surd. Why? Because the order is 2. Inside 27 is a positive rational number and overall or in all root 27 is an irrational number. Okay, now here we have to multiply this surd by such an irrational number so that the product of them will be a rational number. Okay, so let us see now how many rationalizing factors we are getting here. So first of all, here this root 27 we can express in the simplest form. We can express 27 as 9 into 3. So root 27 we can write as root 9 into 3. Here 9 is a perfect square of 3 and therefore root 27 we can write as 3 root 3. Okay, now you will get better idea here that by which number to be multiplied here so that we should get a rational number. So here root 3 is present and if we multiply here by root 3, then root 3 into root 3 is going to be 3. Okay, so in the beginning we can multiply by root 3. So 3 is already present and root 3 into root 3 is 3, which is equal to 9. It is a rational number. So this root 3 is one rationalizing factor of root 27. Let us see more factors now. Similarly, now here root 27 which we express as 3 root 3. If we multiply it by 3 root 3, then see this 3 into 3 is 9 and root 3 into root 3 is 3. 9 3s are 27, again a rational number. So this 3 root 3 also can be a rationalizing factor of 3 root 3. And how we obtain this 3 root 3? By multiplying this surd by a rational number, that is 3. So similarly, we can write down 4 root 3, 5 root 3, 7 root 3, 8 root 3, all are the rationalizing factors for 3 root 3. Okay, so in the same way, we can write down many rationalizing factors because here we can multiply by any rational number. Here all positive are taken, we can take negative also. Because condition is what we should get a rational number. It is not so that we should get a positive rational number. So rational numbers, they can be negative also. Okay, so here we can have innumerable rational numbers. So similarly, we can have innumerable rationalizing factors here. Okay, but out of that, here root 3 is the simplest rationalizing factor. So while solving the sums, always we are going to think of the simplest one so that we can get the correct answer. Okay. So I hope now you got better idea about the rationalizing factor. Now let us see one more example. Rationalize the denominator of 1 upon root 5. Here always you will find that in the question you will have like this type of question only, rationalize the denominator. Never you will have rationalize the numerator. Because here you know that while adding or subtracting or for any operations here, we should have a rational number in the denominator. That is why always the denominator is rationalized so that further there is a simplicity in solving the problems. Okay. So here rationalize the denominator means what? In the denominator we want a rational number. Presently it is irrational, that is root 5. So now by what we should multiply here so that we will get a rational number? So like root 2 or root 3, here if we multiply by root 5, then we are going to get 5, which is a rational number. But we cannot simply multiply the denominator. We have to multiply both the places, in the numerator as well as in the denominator. Okay. So this is an important thing, that you simply cannot multiply in denominator. You have to multiply in the numerator also. So let's see this root 5 and root 5, it will get cancelled and the original number is preserved. It should not get disturbed here. Its value should not change. So we have to do it at both the places, numerator as well as in the denominator. Now see 1 into root 5 is root 5 and root 5 into root 5 is 5. So in the denominator we got a rational number. That means we have rationalized the denominator. Don't think of numerator. We have to only think of denominator. Okay. Let us see one more such example. Rationalize the denominator of 3 upon 2 root 7. Okay, so now immediately you will get idea that here this root 7 is an irrational part and we need to rationalize that. So immediately you will tell that we should multiply and divide here by root 7. Both the places we should multiply and divide by root 7. So in the numerator 3 into root 7 is 3 root 7, and in denominator 2 as it is. Root 7 into root 7 is 7. So 2 into 7 is 14. We have rationalized the denominator. Okay. So such simple sums will come, and they are very easy because here we are going to think of only quadratic surds. That means the surds with degree 2. In the previous syllabus, the surds with higher order also were there, but nowadays the syllabus is made more simpler. That is why all the tough part it is removed. Okay. Now let us go further. So we have to remember that we can make use of a rationalizing factor to rationalize a denominator. We have to observe denominator, and accordingly we have to multiply numerator and denominator by the appropriate irrational number to get a rational number in denominator. As I have said, it is easy to use the numbers with rational denominators. That is why we prefer to rationalize the denominator, okay? Or that is why always we are rationalizing the denominator. In 10th standard also, you will understand that how much important it is to rationalize the denominator. And in higher studies also, when you go for the science or commerce, and when you will take math subject, that time you will understand the importance of this rationalization better. Okay, so don't forget this particular concept. Now let us start with practice set 2.3. From that, the very first question you can solve orally also. In the textbook itself you can write down the answer with pencil, or if you want you can write it with the pen in your notebook. Okay, state the order of the surds given below. So you know that here the in the surd, this symbol is called as radical sign, and the number inside is called as radicand, which is always positive rational number. And here the number which is written in the smaller font, it shows you the order. Now see, try to understand the difference between this number and this number. Okay, here it is 5 root 12. So here 5 is a rational number. So this number is having two parts. One part is rational and the other part is irrational. Similarly here, that rational number is not seen means it is 1. It is 1 into cube root of 7. See, you should understand the difference, how 5 is written here and how 3 is written here. This 3 is written inside this symbol. See, inside this triangle part it is written. Okay, and the font also is small. So that denotes you the order. So here you can observe and you can write down here, like here the order is 3. Okay, very clear. Here the number is not mentioned. So in that case, the by default the order is 2. Don't get confused. This 5 is a rational part. It's not an order. Here easily now you can say the order is 4. Correct? Similarly here the order is 2. And here the order is 3. So it is very easy. You can solve it orally also. So this way we can write down the order, but don't get confused. Whenever you will find that the number is not written, by default it is 2, because we use the word square root. Okay, so that square root word stands for the surd with order 2. Okay, so in this way you can write down the orders. Now let's go towards the second question. State which of the following are surds and justify. That means you don't have to say only yes or no. You have to justify your answer, means you need to write down the reason that why it is a surd. And for this, we have seen three conditions, if you can recall. When we have studied surds, that time we have seen the three conditions. The very first condition is what? You have to observe the order. This order should be greater than 1. That means here the number, it should be 2 or more. This is first condition. Second condition here, the number inside the radical sign, which is called as radicand, it should be a positive rational number. And the third condition, overall, the number should be irrational. Okay. So these three conditions we need to verify, or those three conditions we need to write properly as our justification. Okay. So I'm not going to solve all for you. I'm going to give you the statements and remaining you will solve by yourself. Okay. So let's start with first one here. See, here radicand is equal to 51, a positive rational number. One of the condition from these three conditions given. N, value of n, you know that nth root of a we are saying n is equal to 3, which is greater than 1, and overall cube root of 51 is an irrational number, and that is why we can say that cube root of 51 is a surd, because cube root of 51 is an irrational number, because 51 is not a perfect cube. You know that 1 is a perfect cube, then after that 2 cube is 8, 3 cube is 27, 4 cube is 64. So in between 51 is not a perfect cube. So cube root of 51 is an irrational number. That is why we can say that cube root of 51 is a surd. Okay, the reason is written here. Three conditions, first, second and third. Okay, here you can change the order. Either you can write this first or you can write this first, it will do. Okay. Now second one here. Fourth root of 16. Okay. So for fourth root of 16 here, we can see that 16 radicand is a positive rational number. One condition is verified. N means the order is 4, which is greater than 1. Again, second condition is also verified. But fourth root of 16 is not a surd. Why? Because fourth root of 16 we can write as 2. Okay, you know that 2 into 2 into 2 into 4. That means 2 raised to 4 is 16. And fourth root of 16 is 2, which is a rational number. That is why here it is not a surd. Because we have the condition that overall the number should be irrational number. Okay. Similarly, you can write for third one here. Fifth root of 81. So you can write down radicand is 81, a positive rational number. N is equal to 5, which is greater than 1. And fifth root of 81 is an irrational number. Therefore, it is a surd. 81 is 3 raised to 4. If it is fourth root, then it is again a rational number. Why? Because fourth root of 81 is 3. 3 into 3 into 3 into 3. If you do 4 times, then it is a 3 raised to 4. So if fourth root is there, then it is going to be a rational number. But since we have fifth root here, it is an irrational number. So we can say that this is a surd. Okay. Again for question number 4 here, root 256. You know that 256 is a perfect square. Root 256 we can write as 16. 16 square is 256. So here root 256 is not an irrational number. It is a rational number. Therefore, we can say that it is not a surd. Similarly, fifth one here, cube root of 64. See, 64 is a positive rational number. N is equal to 3, which is greater than 1. But 64 is a perfect cube of 4. Okay. So, cube root of 64 we can write as 4, which is a rational number. So, this is again is not a surd, because cube root of 64 is not an irrational number. Okay. So just don't see the sign here. Try to understand. Root 256 is 16. Cube root of 64 is 4, which is a rational number. Therefore, these two are not surds. Okay. So in the similar manner, see, you can take help of this to write down the answer for this. And for third one, you can make use of first one. Now last one, sixth one here. Square root of 22 upon 7. Generally 22 upon 7 we use for the value of pi. But please take a note that 22 upon 7 is a approximate value of pi. Pi is an irrational number, but 22 upon 7 is not an irrational number. You know that 22 upon 7, it's a fraction and it's a rational number. So here radicand is 22 upon 7, which is the positive rational number. Then the order here is 2, which is greater than 1. And therefore we can say that here that cube root of 22 upon 7 is a surd, because overall this square root of 22 upon 7 is an irrational number. Okay, so this way you are going to write down the justification. Now let's go further towards question number 3. Classify the given pair of surds into like surds and unlike surds. Okay, so this type of solved examples we have seen. So now let us start with first one here. First is root 52 and 5 root 13. So what we can find here is one surd is in pure form, or we can say that it is not in the simplest form. Otherwise the second one is in the simplest form. So let us express this first one in the simplest form. So 52 we can write as 4 into 13. 4 is a perfect square. You know that square root of 4 into 13 we can write down as square root of 4 into square root of 13. And then square root of 4 is 2 and here root 13 as it is. So root 52 we can write as 2 root 13. And the second one is 5 root 13. Now observe these two surds. As I have said, while deciding like surds or unlike surds, you are not going to see the rational part. You are going to observe only the irrational part. If irrational part is same, then we can say that these two surds are like surds. Okay? Because this radicand and the order, they should be same. Then only we can say that these two are like surds. Okay? So after simplifying easily, we can decide. Similarly, second one now root 68 and 5 root 3. So here also 68 we can write as 4 into 17. Always think of a perfect square while writing the factors. Okay. So root 68 we can write as root 4 into 17. And then that root 4 into 17 we can split and write as root 4 into root 17. Root 4 is 2 and root 17 as it is. Okay, so root 68 in the simplified form we got as 2 root 17. And see the second surd now 5 root 3. Now observe the irrational part. Here you have root 17 and here you have root 3. Order is same but radicand is not same. So these two are not like surds. That means they are unlike surds. Okay. So we can say that therefore root 68 and 5 root 3 are unlike surds. Got it? Now next, third one. Third one you will solve as homework. Okay. This root 18 you simplify. Root 18 you can write as root 9 into 2 and that 9 will come out as 3 and here you will get 12 root 2. And here 7 root 2. So they are like surds. Okay. So similarly you can solve. By seeing example 1, you can solve example 3. Now see fourth one, 19 root 12 and 6 root 3. See this 6 root 3 is simplified. But we have to simplify this. 19 is a rational part, so we are not going to touch that. We are going to see only the irrational part, that is root 12. So 12 we can write as 4 into 3. Again 4 is a perfect square. Okay. Then after splitting, we can write this as 19 into root 4 into root 3, where root 4 is 2 and 2 into 19 is 38. So we can write 19 root 12 as 38 root 3 in the simplest form. Okay, so this is 38 root 3 and this is 6 root 3. Observe the irrational part. Irrational part is same. So we can say that these two are like surds. Okay. So simply by observing the original surds, we cannot say whether they are like or unlike. We have to solve, we have to simplify them and then we have to check. Got it? Then fifth one here, 5 root 22 and 7 root 33. See, 22 we can split as 2 into 11. 11 is a prime number and 2 is not a perfect square. So it is not possible for us to simplify this. It is already in the simplified form. Similarly, 33 we can write as 3 into 11. 11 is a prime number, 3 is also prime number. So here for 33 also we are not getting the factors such that one factor is a perfect square. So already these two are in simplified form and you can observe the irrational part. It is not same. So we can say that these two are unlike surds. Correct? Similarly, you can solve sixth one. Now here in sixth one, first one is in the simplest form, but second one is not in the simplest form. So 75 you factorize. So that one factor should be a perfect square. So always think of the perfect square. 1 square is 1, 2 square is 4. So it is not divisible by 4. 3 square is 9, not divisible. 75 is not divisible by 9. 4 square is 16. 75 is not divisible by 16. 5 square is 25. And we know that 25 threes are 75. So this 75 you can write as 25 into 3. And 25 is a perfect square of 5. So we can write this as 5 root 3. So here we got 5 root 5 and there we got 5 root 3. So here root 5 and here root 3. So they are not like surds. They are unlike surds. Okay. So some number first, second and fourth is solved for you. Similarly, you are going to solve third, fifth and sixth as homework. Okay. So mark these three sums as homework. Let's go further now. Question number 4. Simplify the following surds. Already now we have seen the simplification in like and unlike surds. So this is now very easy for you. And 27 we have simplified so many times. So 27 we can write as 9 into 3. Root 27 we can write as root 9 into 3 because 9 is a perfect square. Always we are going to think of perfect squares. Then this root 9 into 3 we can split and write as root 9 into root 3. And root 9 is 3 and this root 3 as it is. Therefore, 3 root 3 is the simplified form of root 27. Similarly, for 50, you can write it as 25 into 2. 25 is a perfect square and you will get the answer as 5 root 2. Then you can solve for 250. So like for 250 also, you know that the perfect square is 25. So 250 we can write as 25 into 10. Split it, root 25 into root 10 and root 25 is 5 and write root 10 as it is. So the simplified form of root 250 is 5 root 10. Okay. Similarly, you can think of root 112. You have to find out a perfect square here and then you have to solve it. Then similarly, you can solve fifth one also. See, fourth one is also solved for you. For 116, you can split it as 16 into 7. 16 is a perfect square of 4. And therefore, 112 you can write in the form of 4 root 7. Okay. Similarly, fifth one, root 168. Now for 168, since the number is very big, but still the factors we can write in the form of 4 into 42 only. 4 is a perfect square or highest factor we can find out which is a perfect square here in case of 168. We cannot get any other factor which is a perfect square greater than 4 because see 42 you can split as 6 into 7. Okay, 7 is a prime number and 6 you can write as 2 into 3. Again, they are prime numbers. So here 4 is the highest perfect square present here as a factor of 168. So 168 we can write as 4 into 42. And the square root of 4 into 42 we can split as root 4 into root 42. then root 4 is 2, and root 42 as it is. Okay. So this way we are going to write down the simplified form of the surds, and this way we can simplify the surds. Okay. So now here first, third, fourth and fifth is done for you. Only you have to solve question number 2 as homework. Okay. So students, there are more questions in this particular exercise, but we will do it next time. Okay. So students, I am stopping here today. We will meet in next lecture. Till that, you stay home, stay safe, take care of yourself. Thank you, students.